get started. Thank you guys for all being here. I know it's really late and we want to go eat dinner and stuff, but we'll make it quick, I promise. We have a great talk prepared for you guys today on how we built a highly scalable AI search engine and AI data lake with Kubernetes and LanceDB. I'm Chanchan. I'm DevRel at LanceDB, and I'm here with Lou, who is a data engineer at LanceDB as well. Okay, so before we get into how we built this, let's kind of start with why. So today, everybody is interested in AI. Everybody has the same access to the same models, to the same advanced techniques. So when you're building an AI feature for your company, what really differentiates your AI features from your competitors' AI features? And the answer to that is data, specifically your data and how you connect your enterprise data to your AI features and agents. And that's what really sets apart a commodity from a differentiated AI product. And so there's three ways to think about data. There's volume, velocity, and variety. These are the three V's of data, which are very different today because of AI. So first is volume, the amount of data that you're dealing with. AI data is just so much larger. Tabular data is pretty small. Each row is about 150 bytes. You add on OpenAI embeddings, which is already an order of magnitude larger. Then you start adding images and videos. Now we're at several orders of magnitudes larger than what we started with. And this is still all in one single row. So somehow we went from about 145, 150 bytes per row to now almost 50 megabytes. So that was volume. Now we are at velocity. Sorry, that should be velocity. Velocity is the speed at which data is being generated. Velocity is much higher now. Because of AI, we're no longer generating data based on human input or manual input. We're generating that data automatically via models at hundreds or even thousands of tokens per second. So now not only is data larger, they're also being created much faster than before. And lastly is variety, which is the kinds of data that we're dealing with. AI applications and AI models are often multimodal. It's not about numbers, dates, and strings anymore. There's also prompts, long-form text, images, videos, and embeddings. So with all of these three V's together, it's pretty clear that traditional data infrastructure meant for tabular data is not really designed for teams trying to build the next generation of AI applications, infrastructure, or models. If you're storing data, especially multimodal data on a traditional data lake, you often result in a very fragmented system where parts of your data are stored in one format for one particular use case in one particular system. So to create a complete workflow or pipeline, you're actually spending a lot of time trying to piece together all of these different parts and trying to keep them in sync. You're also paying for extra infrastructure costs for these multiple systems and copying data back and forth. So when you have to manage so many different systems, that's where a majority of your time is spent instead of actually building features, which results in drastically reduced productivity. So naturally, the next question to ask is there a system that makes storing and working with AI data much easier, that's less costly and can improve engineer productivity? And the answer is yes. That's why we are building Lance, a new storage format, and LanceDB, a new multimodal lakehouse for dealing with AI data. So like before, instead of having a fragmented system with particular tools for specific tasks like search and processing data or analyzing and training data, with LanceDB, you now have a single place to put all of your data in a single table on object store. You have the ability to incrementally enrich your data with additional features without copying that original data. And you also have the ability to run multiple workloads with compute storage separation in the same system. And finally, it's open source, and it plugs very nicely into the existing open source ecosystem. So you can use Spark or Ray or PyTorch to process and train your data. So what we're building is what we call the AI native multimodal lakehouse. It's built on Lance format that allows you to store text, video, audio, and sensor data in one place. And then on top of that, you can run your search, analytics, training, and pre-processing workloads. And again, this is all in one system. So LanceDB today is already powering the future of multimodal AI at a number of companies. We have partners at large tech companies and data infrastructure providers that are using LanceDB, like Netflix, Databricks, ByteDance, and Uber. Netflix actually published a blog post recently on how they use LanceDB's multimodal lakehouse as the foundation to build what they call this media data lake, storing their video data, audio tracks, text subtitles, and so on. And with LanceDB, Netflix has unified petabytes of multimodal data and ML embeddings into one queryable system to power ML training, content search, and quality metrics. LanceDB is also powering frontier model companies like Midjourney, World Labs, Runway, and Character AI, to name a few. So if you've ever generated an image or a video with any of these companies, now you know that many of these models are actually backed by and trained on Lance format. For example, Runway chose LanceDB because it transformed their massive multimodal training data into a searchable, evolvable, and collaborative data platform, enabling scalable model training, fast iteration, and integrated data-to-model workflows. And lastly, cutting-edge agent companies like Hex and Harvey that are doing automation on data analytics are all on LanceDB. Harvey uses LanceDB as its AI-native data foundation to unify massive legal corpora, power low-latency semantic and keyword search, and support secure, scalable RAG across sensitive legal data. Awesome. So now I'm going to pass it off to Lou, who will now dive into the features and internals of LanceDB.
Thank you, Chanchan. Hey, so I think Chanchan gave a really good introduction. Then I just dive into the technical details of how we actually do that. And the first question, can I leverage all my multimodal data, and how can I leverage that? We basically build something called Lance format. Lance format is the open source standard for multimodal data. It's a columnar format that you can dump all your multimodal data, image, audio, embeddings into your cloud storage. And you can dump millions or billions of such information. So it's cloud storage based. So if cloud storage doesn't have a scalability limit, we don't have a scalability limit. And if you guys are familiar with the Iceberg plus Parquet, Parquet is the old columnar format on cloud storage that built for the data analytics, built for fast scan operation. But we basically build everything for multimodal data, for your image, for your videos. And we power different AI applications like Dossier, which I also have a talk today at 2 p.m., and also Continue, the biggest open source coding agent. And we have some blogs actually talk about how we design Lance format. We originally tried to do some incremental improvement on top of Parquet. For example, a row group is a concept that is widely used in Parquet. It can group different columns together in a row group. But that doesn't work well for multimodal data. For example, you may have some small columns for your tabular data, like your name, and you have some large column for video. When you actually put those two into one row group, then it's very hard to decide what's the row group size. If the row group size is too big, then that means your name column maybe have thousands of rows or millions of rows. But if you put it too small, then you maybe only have one image or one video. So we removed that concept totally, and then we redesigned the whole thing called Lance format. And we have a bunch of really in-depth blog about how we actually create the Lance format, what design decision that we made to create it, so you can scan those and to read those blogs. They are a lot. On the other side, you may not come with your multimodal data in the beginning. In the beginning, you may only have your image or video data set. That's on the left side. You can see you may have an image column. You may have a million images. But how can you actually leverage them for your AI application? You want to extract information from that image column. And you may want to run it through multiple different models to create different captions of it. This image is about two people fighting each other, etc. And you may want to compare different models and see how they capture the information, how well they capture the information. And also, you may run your image through some Python libraries to get some metadata, like how wide and how height of that image. And you may want to generate a column that based on your previous columns. So all of this called feature engineering. It helps us to actually extract useful information from your original data set. And we made it really simple. So in Lance format, we define a thing called user-defined function. So basically, the input is one column. The output is another column. And you define that how I want to transfer one value in this input column to one value in that output column. You can define like some Python library or some models that you want to run through, and we help you to apply that to all the rows. So consider you have millions or billions of rows. We help you to apply to each of those rows. And that sends to our Lance format. The Lance format is a columnar format. So if you want to create a new column, we won't modify your old data set. We just create a new file, a new data file with your new column information. Now about like, you already know how to dump all your data into this multi-methodal like Lance format. But how can we actually leverage it? Leveraging it is not just like this one, I think Chanchan already showing. It's like how can we do all the operations using this multimodal lakehouse? We actually build everything into Lance format. And the reason that different AI applications can actually use Lance format is because we fundamentally change how we access the data. Like Parquet do really well in fast scan for tabular data. And for Lance, the reason that we build everything from scratch up is that we want to support really good random access operation. So we have the scalable disk-based indices that also located in the cloud storage that can help you quickly find out the rows that you actually want. And for those rows, you need to quickly access all the information about that row. And for Parquet, you need to go to your cloud storage. You may need to scan a bunch of data to really know that's the row that I want. But with Lance, because we build things into the metadata, we have something called row ID, which can quickly help you locate to which file and which offset in this file. So we can quickly do the random access with several operations. So it turns like O(n) complexity down to O1 for random access. And random access is very critical in the Lance format because of this nature, so we power rich search. We allow you to do full text search when you want to search a long document, your logs, your natural language data. And also we support like vector search that allows you to do semantic or embedding workloads. We also have support like SQL search for structured query. And Lance dataset already integrate with the whole ecosystem, like Ray and PyTorch for data training, Spark and Chino for data preprocessing, and also data analytics. Basically, you have a single source of data and supports you to do different retrieval. You can run your familiar SQL queries on this data set. You can do the full text search on this data set. And also, you can do vector search. And many of you guys, usually when I give a talk, many people is like, I don't really understand about what's vector and what's full text search. It's towards the data domain. And I will have a short demo to actually show you guys what did that mean. I may need help. Okay. Okay. I can just go through. Okay. Great. So this is a demo. This basically shows you how to cook with LanceDB. I use the food recipe example because like I'm really into food. And it's pretty simple, and you just like get through something set up. And the key point is here, you import LanceDB, and then you define how your data set looks like. And here I found a data set from Hugging Face, which contains the ID information, some task columns like title, ingredients, and also how to cook this food, and the author, and different information. And also the vector, which catch some semantic of those task columns. And I just ingested the data set from Hugging Face. Yeah, I created this one on the fly, so this is the best data set I can find so far. And on the other side, I can create different index for different columns. So index really helps us to quickly search through the large data set. It turns O(n) complexity to a tree structure that you can quickly locate the information that you want. So here I create full text search for the text columns. I can also I don't need to create the vector index for the vector column because that's already created automatically. And you can take a look at what those data sets look like. The title, the direction, the ingredient, and all the information. And now I start to doing the search. Full text search is what I call exact search. So I already know what I want. Then I just need to search through those keywords. I already know that I want some dessert that with lemon and cream. Then I just search lemon and cream. And it will give me the recipe that actually use those ingredients. And vector search, I sometimes call it mood matching. Basically, consider there was a night that you ask your husband or your wife about, oh, what do you really want to eat for dinner? And your other half may answer to you that, I don't really know, but I feel like something cozy, warm, and soft. It doesn't really make any sense, but it makes sense to your models. The model can understand the context and find the best match for something like cozy, warm dessert. And then the data, so we do vector search here. It actually helps you to find some of the data set that fulfill the vague requirement. So sometimes I call it like mood matching, or maybe like vague searching or other things. And we can combine these two together. We can do the keyword search together with vector search. One thing catch the keyword, and the other thing catch the meaning of it. And then we can combine together and then search the, basically it runs through full text search, and then it runs through vector search, and then we combine the result together to form your final results, which contains lemon and cream and also like some soft, cozy dessert. And we not just want to do the search. We may have some rules about what kind of recipe that I want to get from my data set. I don't want something like salad or some soup. Sometimes they show in the results. And then I can say that, oh, find me the rows that don't have such stuff. So that's the filter that you can add on top, or that's the SQL query that you can add on top to form the rules. And on the other side, I can also do a bunch of like filters. Unfortunately, my data set is not good enough that it doesn't have that many columns that I want. But basically, the idea is like the data set, I don't want to get a random recipe from this recipe repo. I want to get a recipe that is actually validated by multiple users already, not some crazy data set that created by some random dude. And I can search like, I want those recipes have been already tried out by more than 1,000 people. I want this data set to have a 4+ review. I want this data set created by some trusted author. So I can add those rules to it so that the search doesn't actually make sense for me. And lastly, I will build a really simple agent with LangChain. So first, I just define all the vector search, full text search, and hybrid search functions that if you want to run those search, what should you do? And I create a really simple LangChain, basically like you are a dessert search like assistant. And then based on the user request, if it contains like keyword, then use full text search. If it's very vague or mood, or like talking about mood, then you use like vector search. If it contains both, then you do a hybrid search. And this is a user input some query, and you turn it to the JSON format. That is actually like helpful for us to decide which function I'm going to call. And then the chain is about basically linking different things together. So when you give your user input, it will run through the LM model with that prompt and generate a JSON result. And based on the result, we can decide like, oh, I run it through vector or full text search or hybrid search and get the result that you want. For example, I just give in a really simple like input query. I want a cozy orange dessert, but no salad or soup. And it will translate that to a hybrid search query that is like, okay, cozy orange dessert, and that's the filter that I want to like filter against. And it will give you the results that fulfill your requirement. And that's agent. Agent help you to make decisions, or agent help you to combine like different steps into one step. And I will go back to our talk. Yeah, this is a QR code that if you want to copy it and run it yourself. And we have the same code that you can run it with your local disk. You can store the data set in your local disk. And you can also run it with our LanceDB Cloud or LanceDB Enterprise. The code is exactly the same. The difference is who manages the infra and also about the scalability. And so LanceDB first came out as a vector database. And many people is oh, are you guys just another vector database? Why do I need to use you guys? Vector database? No, it's we don't need another separate vector database. It's just a file. It's just an index file that's stored in your cloud storage together with all your data. And this is our whole enterprise stack. So you store the lens format in the cloud object storage. And the benefit of it is we can turn your 1 million vector storage price to reduce from $180 per month to only $0.25 per month. That's basically the memory price compared with object storage price. And you can store your really large, millions or billions of rows data set in the cloud object storage. On the other side, we have the query fleet. Each query fleet is just a query node that runs import LanceDB, the thing that you already see. Import LanceDB and do the search. So it's nothing fancy. You can actually build this whole enterprise yourself. So if you have more requests, more search requests, we just launch more query nodes. If you only have several operations per second, then one query node is enough. Your local mapbook is also enough. But if you have tens or thousands of requests, we can add new query node based on your need. So it's auto-scaling, thanks to Kubernetes. On the other side, we also have the cache ring, which is also on Kubernetes. The cache ring helps us to cache the frequently used data to provide better read performance or better search performance. And this one is also auto-scaling. If you have more data than want to be cached, then we launch more nodes for that. And yeah, it's auto-scaling and it's stateless, which is perfect for Kubernetes. So the query node can go down at any time, and then they can come out at any time. You can add as much as you want as you compute elastic. And this is a huge difference compared to other vector database or other search engine. It's we have the compute and storage separation. Query node is fully in Kubernetes, is auto-scaling, while all your data set, the single source of truth, stay in cloud storage. On the other side, we have some write optimization. So we have what we call automatically launched indexer pod, or we call async optimization. Basically, when you write a bunch of data, it results in small files in your object storage. But small files create some physical boundary when you try to do the read operation, or when you try to read a bunch of data really quick. Because you need to read multiple small files in multiple operations instead of reading one operation to read a bunch of data. So in that sense, the indexer pod or optimization pod, what we do is we combine the small files into large file to boost your read performance. On the other side, our search performance highly rely on that your indices are very key up to date. So index is really quick to help you to find the data that you want. But index sometimes can be out of date. If you write 500 rows and create an index on that 500 rows, then later on you want to write another 500 rows, then it will result in a scenario that you only 500 rows you can go with a fast path, and the other 500 rows need to go with the slow path. And so keeping index up to date is very important. And we launch indexer pods on demand to help you to boost that, to make your index up to date. So we either create a separate incremental index for that new 500 rows, or we think that your old index is very out of date, we just create a new one. And all those things are automatically launched on demand. So our indexer pods are launched on demand based on our analysis of your data to decide which optimization you need to put to optimize your read performance. Yeah, that's it. And if you have any questions, then join our Discord channel. And also, we are hiring, as always. Thank you. Let me know if you guys have any questions. Yeah, it's a Kubernetes conference, but it's very like towards the AI and data field, so hopefully it's not like too hard to understand by you guys. Any questions? There is a. Thank you.
So most of the data lakes already have their data in Parquet format or Iceberg format. How do you guys see that data being available to your?
Sorry, can you speak louder? Sorry.
So most of the data lakes have their own data sitting in some format, existing format, right? Mm-hmm. So how do you see your system getting integrated with that existing data?
I just understand the question. It's like how you compare you guys to other format, or?
So let's say you already have some data in Parquet format sitting.
Oh yeah.
Right, which is being accessed through High Metastore, through Trino. So how do you see that being integrated with the multimodal data lake which you guys are proposing here?
Yeah, so if you already have some workloads that run on top of like Parquet format, for example, Trino already run on top of Parquet format. If that really works well with your existing data, you only have tabular data, don't need to change to us. But many of the people that come to us because like their Parquet format cannot fulfill their need. And they use Spark or they use other ways to ingest data, and also Arrow. Like you can read the Parquet file and then dump that into like Lance file. And then the Trino can also read the data set from the Lance to actually do the analytics.
Right.
So
thank you.
If you only tabular data, then probably the two part is similar. Right.
Yeah, but like let's say if you want to add now the images to your mix, right? So do you see that that whole data set in Iceberg format or Parquet format needs to be ingested somehow, or you can have this image data set sitting independently but still works with multimodal data lake?
Yeah, basically in your way, it's like you can go with the old Parquet way that you put image as a link. Like you can basically put image on your cloud storage and then use a link in your like Parquet file. That one, I think this is the one way that many people already do in their like system. And the difference between that one and us is like we also manage the image itself together. So you can have one row that have the image, have the embedding of this image, have the caching of this image, basically all together. So that's the difference. It's like you don't need an actual system or actual way of managing those image or video.
Okay. Thank you.
Thank you.
Yeah, okay. I had a question on like the cost of storage plummeting, like that factor is insane. I guess I had a question on then how does the Lance format handle, I guess, like data sparsity, or because like storing a document like as both like raw text and then also as a bunch of vectors of like embeddings, I guess, yeah, how does that handling that like size complexity work with Lance?
So I try to understand your question. It's like you basically mentioned that if you already have a bunch of data there, and how can you integrate with Lance format?
Or I guess like how does Lance store the data in like I guess like a storage efficient manner?
Yeah. So I think that part is not too different from Parquet in the sense that you store it as some blob, like some compressed data. And the difference is like, so basically if you have a video, it's not just you store the whole video directly. It's like we actually chunky and put different chunk as different blob inside our Lance format. And, but the difference compared to other format is like, because we want to support random access, so we need to make sure that the compression format, we don't need to compress the whole block to get one row. we need to be able to already know that even if it's compressed, I know that my row locates in where, and then I directly go find that one.
I see. So it's like compression and then also storing the, I guess, like metadata about said document.
Yeah, we stored a metadata. And there is actually like interesting about like how we use very compressed metadata. Like each number may have 5 meanings. So basically, when you do the index, you run through the index, and then you search the stuff, and then it will give you some row address. The row address already tell you that this row locates in which file and which offset of that file. And then that length format file contains the metadata to tell you that, oh, this offset of this column locates in this place. So the gist is like we have metadata to know where it is. And our compression rule allows us to just decode that row. Yeah. Do I answer your questions?
I guess I have another question if that's cool.
Yeah, go ahead. Yeah.
I guess on another topic, for like the slide where you had basically like the access with like the cache access and then also having like multiple fast read writes. I guess how does Lance handle the consistency between that?
I think the consistency is really central to Lance format because Lance format itself have the metadata, which they already give you what version is the source of truth. So we have in Lance format there have a version folder, which only one writer can succeed in a time that successfully create a new version. So every write results in a new version, and that's all the source of truth for everything. And on our read part, you can decide your consistency level. You can be like, I want it to be really strong consistency. For example, our Harvey, the legal company, because the new data is the most important data, so they want strong consistency. Then the compromise part is like it will sacrifice a little bit of performance because we do need to know which version is the latest version. And we also made that really efficient. But even if it's the most efficient, you need one operation to know which version is the latest version. So in that part, we get the latest version, and then we ensure that you are always reading from the latest version. But if you don't care about consistency, or you can tolerate a little bit of like eventual consistency, like 30 seconds to 60 seconds, then we only need one operation per 30 seconds or 60 seconds to find out the latest version. And all the data file is immutable, the metadata file is immutable. So if we already load it, then we'll just reuse it.
Thank you.
Thank you. Thanks for staying late for the talk.